A bit of background before we hand it over to Mike. I want to start by talking a little bit about TransformTO, which is Toronto's climate action strategy to reduce greenhouse gas emissions to net zero by 2050, while creating a low carbon future for Toronto that is healthy, equitable, and prosperous that benefits all. A bit of some of our long-term goals as part of TransformTO. The one we're really looking for and be working towards as a city and more is we're trying to reach net zero emissions by 2050. In terms of how we'll get there, we're looking to retrofit 100% of existing buildings by 2050 in order to reach that net zero target. So big goals here, and so it's really important that we kind of start working towards those now. In terms of Toronto's emissions, I'll just direct your attention to the graph on the left first. So that's kind of a highlight of Toronto, where Toronto's greenhouse gas emissions come from. And you can see from the green, section there, the majority of them come from buildings at 55%. In the graph on the right, so those are the emissions by building type, where again, 55% come from residential homes and buildings. So it's kind of the majority of the majority. And that's why we're really kind of focusing in on the residential sector for emissions and for really reducing them as best as we can, because it's clear here we can make that big impact if we focus on that sector. In terms of some of the city's programs for home energy efficiency, we have a few. The first is BetterHomesTO, which is Toronto's guide to a comfortable and climate-friendly home. So this is part of a resource arm of our office, provides all sorts of information and a one-stop shop website available at betterhomesto.ca. It includes information on the EnerGuide home evaluation, so the energy audit that you would do of your home, some of the upgrades that we would recommend if you want to kind of reduce your greenhouse gas emissions coming from your home, and some of the current rebates and incentives available. We also run the Home Energy Loan Program here at the city, which is the City of Toronto program that provides low-interest loans to homeowners interested in undertaking energy efficiency, water conservation, and renewable energy work. So this program, for instance, would have been, eligible for Mike's retrofit that he's going to be talking about today. So just a couple of the resources that are available from the City of Toronto. And if you have any questions about them, please feel free to put them in the Q&A box, and we'll try to get to them through the session. Also, I want to just provide a very quick update on the rebate programs that are currently available for retrofits of your home. The first is the Canada Greener Homes Grant. This is a recent program that was announced by Natural Resources Canada a couple of months ago, and it offers grants of up to $5,600 to complete an EnerGuide home evaluation and various energy efficiency retrofits to your home, including the installation of heat pumps. So that's something to kind of keep in mind for everybody, and Mike will talk a little bit more about that. Also available is the Enbridge Home Efficiency Rebate, which offers a rebate of up to $5,000 to complete various upgrades to your home, and an additional rebate for an EnerGuide home evaluation. Again, if you have any questions about either of those rebate programs, please feel free to ask them during the Q&A. Now, before I hand it over to Mike, I just want to mention that we are incredibly grateful to have passionate and knowledgeable residents like Mike that are willing to share their retrofit success stories. As some of you may know, the Net Zero Existing Building Strategy was passed by Council just about a month ago, which calls for bold action on decarbonizing all of Toronto's buildings and homes, including calling for a home energy labeling policy for all of Toronto's homes. As such, it will be increasingly important for us to highlight projects like Mike's to show Toronto residents how to kind of get their homes to net zero. So an important, part of that. So without further ado, I'd like to introduce our special guest speaker today, Mike Kurz. Mike is a longtime Toronto resident and first-time homeowner as of last year. And today he's going to outline how he got his home completely off of fossil fuels. So Mike, over to you, and I will make you a presenter. And take it away.
Okay, thanks very much, Ariana. If you could just confirm that my presentation is available, or is it visible here?
Not seeing it yet. So I may have to not share mine. Oh, it's coming up. There it is. You're good to go.
Okay, perfect. So first of all, I just wanted to thank the city so much for hosting me. I'm very passionate about this topic, and it's awesome to have an opportunity to share my experience, so thanks so much for that. And thanks to all the environmentally conscious people that took time out of their day to listen to my story and hopefully come across some actions that they might be able to take as well. So thanks for the awesome introduction. A little bit more information about me here. I'm from Toronto. As Ariana mentioned, I first bought my house last year. And when I first brought this up with the city, they kind of said, oh, it's really awesome talking to a normal person about like how they did this in their house. And it's cool that they thought I was normal. But there's a few reasons why I was able to do this, including the fact that I'm a mechanical engineer and I work in energy efficiency as my job. So that gave me a few advantages that I'll talk about later. And I don't think you should have to have this background to be able to live your environmental values. So that's a big part of my, my presentation today. So quick outline of what I'm going to talk about here. The first part is going to be kind of the why am I doing this? The second part is going to be what did I do? And then the third is going to be overall results. So why did I decide to cut fossil fuels, first of all, and why am I giving this presentation? It's a lot of work. It was a lot of work documenting my project, and it was a lot of work putting together this presentation. So I thought I'd explain, why I'm doing that. So the first part, why did I decide to cut fossil fuels? It kind of goes without saying, I'm sure everyone on this call is familiar with the risks of climate change, but you kind of have to say it anyway. Being an energy efficiency engineer, I kind of objectively knew the climate crisis was bad, for a long time. But for me, this report that came out in 2018 called the SR 1.5 report from the IPCC was kind of like a turning point for me, to the point where I decided I needed to take more drastic action. And it made me realize that, we're not talking about some abstract future of the children anymore. Destabilization is possible by 2050. That's around the time I'm planning to retire. And I do want to retire into a stable climate. Last week, the AR6 report came out from the IPCC, so I have to mention that too. Basic summary is it's us. They're changing their wording. It's unequivocally human caused. It's bad. Many aspects are irreversible, and we need to stop burning fossil fuels as soon as possible. And some of the high-up officials at the UN referred to the report as a death knell for oil and coal and a code red for humanity. So I think this kind of lays out the reasons why I'm trying to eliminate fossil fuels from my life. Another reason, so why am I doing this webinar? There's some photos I took at the Fridays for Future protests in Toronto back in 2019. And what these protests kind of suggested to me is that there's huge public demand for climate action. Polls show that people favor climate action heavily, and people want to do something to be a part of the solution, but I'm guessing they don't really know how. So their desire comes out in the form of frustration and public protest. So part of my presentation is just to say that people are doing things, you're not alone, there's momentum building. However, there are a lot of roadblocks that I want to talk about. And so we're gonna get some old-timey Batman graphics here, jumping out at you here. Bam, electric could cost more. How? We've only done this a handful of times last year. Bam, you're gonna downgrade to electric? Suck, natural gas is so efficient. So I think it's important that I highlight that these are comments that I encountered throughout my project, and they came from people with the power to influence my decision, including energy auditors, installers, the contractors, and reps from the utility. So even myself as kind of an energy professional, as an engineer, it was hard. It was hard to push that past the doubt cast by these comments. And I found the #1 barrier to implementing this project was struggling to overcome this kind of status quo bias. So I was able to overcome it, you know, with my knowledge as an engineer, and I was able to do kind of all my own background calculations, figure out whether I thought it was going to work and get enough confidence to do it. But as I mentioned at the start, it's not reasonable to expect everyone to do this. So these, in my opinion, these types of comments and culture is what is standing in the way from environmentally conscious people like you on this call, from being able to live within your own sustainable values. And when I moved into my house and was burning fossil fuels, it was a struggle watching, you know, the pollution spewing out of the side of my house. And now I feel a bit better living within my values, and I'm hoping to help some other people be able to do that too. Another major reason why I decided to do this webinar was I read this book called Being the Change by a NASA climate scientist named Peter Kalmus. And the basic premise was that even though it's clear individual action isn't enough to solve the climate crisis, you know, one person's action has ripple effects and can spawn more actions, and eventually the culture starts to shift. So I really like this quote, you know, let's explore a more meaningful life just without all the fossil fuels. So I'm hoping this webinar can help to create a story that, you know, makes it a bit more normal not to be burning fossil fuels at all of our homes. I wanted to demonstrate that there are no technical barriers to ditching fossil fuels. You can save money by doing it, even switching from gas to electric, which I find is a common myth that I see in media articles, that heat pumps, you can only do it if you have fuel oil boilers or if you're on resistance electric heating. I wanted to prove that this type of project can be done fairly quickly and cost effectively. And I wanted to give you folks and others an example so that when your contractor says they can't do it, you can say, hey, I saw this guy, Mike, he talked about it and he did it and he saved money, like give me some more options type of thing. As I mentioned, environmental values, I wanted to inspire government actions, maybe help inform some of their retrofit programs and rebate programs. And I wanted to try to dispel the myth that natural gas is efficient or clean. So on that last point, why should I cut natural gas? It's called natural, right? It's got to be clean and good. So that's kind of just a coincidence of history, but that it was called natural gas. It wasn't some devious plot, but natural gas is a fossil fuel. When you burn it, it emits CO2. There's the ratio there, 1.9 kilograms per meter cubed. However, that's not the only emissions associated with gas. There are numerous studies that in the US and Canada that show that methane emissions, gas is primarily composed of methane. Methane emissions at oil and gas facilities are underreported by between 1.5 to 4 times. Methane itself is 80 times more potent than carbon dioxide in terms of global warming. So by some measures, the true emissions of natural gas are actually double. And in terms of greenhouse gases and climate change, by some measures, gas is as bad as coal in terms of the environmental effect. Obviously, gas burns a bit cleaner, is better from a particulate pollution standpoint, but in terms of climate change, it can be as bad as coal. Now, why electrify? So here's the breakdown of the grid mix in Ontario. Only 7% fossil fuels. So we're lucky to live in a province where almost all of our electricity is emissions free. The average emissions factor here in the bottom right, 32 grams of CO2 per kilowatt hour. You can convert a meter cube of gas into a kilowatt hour by the factor of 10.3. And burning gas essentially on a 1-to-1 ratio is about 13 times worse than the Ontario electric grid. So it's important to mention this is Ontario specific. If you're on a dirtier grid, you might have to, say, install solar panels or purchase renewable electricity to offset the impact. As an example, the Alberta grid has an emissions factor of 570 grams per kilowatt hour, so almost 20 times higher than Ontario. In that case, it's not as clear whether you're saving emissions by going electric, but like I said, you can buy solar panels or purchase renewable energy. So that's the why. Let's move on to the steps I took, how much did it cost, savings, and any other considerations. So the key step in the first step in any decarbonization project is to reduce the overall demand for heat in your house. Electricity costs more on a per unit energy basis than gas. So you want to reduce the amount of heat you need before you switch over. Next step, convert your fossil fuel appliances to electric. So there's a list there of typical ones that people have. And then another key item is to have a plan. It's kind of shocking to hear that almost 90% of gas appliances are replaced kind of in an emergency situation, like, you know, a boiler failing in the middle of winter. And when that happens, you're going to take whatever is available to get the heat back on. So you need to have a plan. If you have some old appliances, start getting quotes early and figuring out how you can decarbonize them. And then this is the step I'm on, talking about it. Spread the word, make it more normal not to burn fossil fuels. A little bit of background info on my house. It's, I don't know, I think fairly normal house. It was built in the 80s, 3 stories. I have my daughter and wife living with me. The pre-existing fossil fuels were gas furnace, hot water tank, and a range. A bit of a disclaimer, my analysis is specific to this house. Each house is kind of unique. You might have to take different actions, more actions, maybe less. Some of these might not apply. And the numbers might come out different. For example, if you live in a colder region or have higher energy consumption. So the first step for me was reducing heat demand. And the key thing here, I knew I had to get attic insulation. And the key thing here was, in order to get a rebate for this, I knew I needed to do an energy audit. So they came in, this photo on the right-hand side here shows a blower door test that basically negative pressurizes your house to find where the air is leaking in. They looked at my attic, verified I needed more insulation, and they found where I needed to do some extra caulking and sealing. This photo at the bottom here shows my house here with a lot of snow not melted on the roof. My neighbor's house, hopefully he's not watching, but all the snow melted on his roof because there's so much heat escaping from the attic. So insulation works. And then bottom left here is the programmable thermostat. I aggressively reset my temperature set points in winter to try and reduce gas consumption. So some of the costs and the savings associated with reducing heat demand. The insulation, 1,000. The energy audits were about 700, doing a before and after. I got a rebate at 1,400, so the total upfront was only 350. Now the savings, it's kind of hard to estimate exactly, but I guess it was around a 10% reduction in heating demand. So the payback there is not, you know, mind-blowing, but the key thing to note is the purpose of this is to conserve heating demand so you can make better use of your non-fossil fuel heat source. The next step for me was to replace my gas-fired hot water tank. So there's a beautiful photo of my new electric hot water tank in my mechanical room there. The reason why I went to this step next was because I had an insanely expensive tank rental contract that was costing $38 a month. So I thought that would be a good place to start to reduce my monthly utility costs. Couple points about electric hot water tanks. They're typically more reliable. They last 25 to 50% longer than a gas hot water tank, and that's just because they have less moving parts. It's just a heating element in a pressure vessel, essentially. Electric tanks are typically cheaper to buy up front, usually a couple $100 less for equivalent models. Now I'm going to talk a bit about efficiency, and you'll see this as a theme throughout. The efficiency of my gas water tank was around 67%. What that means is for every unit of energy you put into it, about a third of that was getting wasted. For the electric, only about 8% was wasted based on heat escaping through the tank. So big improvement to efficiency by going electric. One thing to consider, gas has a lot of power, can heat faster than electric. So if you have high water consumption, you might want to consider a larger tank when you're switching to electric. That being said, I got a 40-gallon tank to replace a 40-gallon tank, and I've had no issues. The last point is it might be difficult to electrify a tankless system. So because gas has a lot of power and can deliver heat fast, many people have a smaller system that basically heats the water instantaneously. And providing that much heat through electricity would be more expensive and difficult. So let's look at the costs that I incurred. The tank itself was about $1,000. And I just wanted to mention, I bought a more expensive tank that had a lifetime warranty. Kind of a similar unit with a shorter warranty could be had for about $600, and a gas equivalent would be about $800. But I went for one with a long warranty because I just, didn't want to worry about it. Shipping, and then I had to hire an electrician to put in a new electric feed. So my total cost was a bit over $2,000 for the water tank. The impact to utilities, and this is kind of interesting. So I saved about $100 worth of gas, but electricity is more expensive. So I actually added costs in terms of fuel to operate the tank, added $300 to my electric bill annually. But like I said, I had that crazy rental contract, so I'm saving almost $500 a year on that rental contract. And you might not have that, so I'm going to look at a scenario later in the presentation where I totally get rid of the rental contract savings. But my overall savings for my house on doing this was $237. If you're more sensitive to paying your electric bills, and you don't want that huge cost increase, there is an option to get hybrid electric heat pump water tanks, and they use about a quarter of the power of the resistance tanks. So you could save money over gas. I ended up going resistance just because it's a simpler system. It costs a lot less than the heat pump system, less moving parts, and it had a really good warranty. So I accepted the higher electric cost in exchange for that. The next step for me was to replace my gas range, going from this, the typical appearance of my gas range before, to this. So the cleanup, amazing, totally different. Never burnt a single thing onto it after I switched to an induction range. But cleaning isn't the only benefit of ditching your gas range. The biggest one for me was safety. So the first issue is I have a toddler in the house. She can reach the knobs and potentially blow things up. Second issue, indoor air quality. So there are a number of studies that show gas ranges increase the indoor air or decrease indoor air quality below national standards in Canada and the US for indoor air pollution. So the pollution from the stove is higher than all the guidance that's provided. And the impact of that is children in homes with gas ranges face a higher increased risk of asthma and various other lung ailments. I don't want to be too alarmist. I know I have like alarm bells on the slide, but this is about a similar risk to living with a person who smokes cigarettes. The Climate Council of Australia estimated 12% of all childhood asthma was caused by gas cooking. Anyway, the bottom line of this for me, kitchen's supposed to be a place of learning, joy, family, fun, cooking, and I just found with the gas range, it was kind of a stressful safety hazard, and I just didn't want to deal with that. I've been so much happier with the induction range afterwards. Some key safety features that are unique to induction. The way induction works is the element generates a strong magnetic field that actually causes the pot itself to heat up. It's pretty cool. So the cooktop itself doesn't get hot. I mean, it retains some heat that transfers from the pot onto it, but as soon as you remove what you're cooking, the heat goes away quickly. It's really good for reducing the risk of burns and stuff like that. If you turn it on when there's no pot, nothing happens. It's awesome. And if you take the pot off, it turns itself off automatically if you forget. So fantastic safety features. Obviously, you're not burning gas, so there's no combustion-related air pollution, and the exploding risk is gone. Back to the story on energy efficiency. I knew gas ranges were bad because every time I touched a pot, I'd burn my hands on the pot handle because all the heat's going around the outside of the pot. But when I actually read this study, I was shocked, 40%. So more heat is going outside your exhaust system than into your food. A gas range is probably more aptly described as an outdoor air heater. It's so inefficient. And here we have induction and electric with, a reasonable level of efficiency. A few other considerations: you need compatible pots. A good way to check is take a fridge magnet, see if it sticks to the bottom of your pot. I didn't actually have to buy any new pots. All of mine worked. I did buy one new frying pan. Getting used to the new controls. Some people might find it a bit hard going from the analog dial to kind of a digital 1 to 10 scale. It took a couple times, but I'm used to it now and it works fine. An interesting thing that I came across is if you have an implanted medical device, it came up a few times that they were saying you should check with the manufacturer to see if it can be affected by the magnetic field. So I just wanted to make sure I mentioned that. So the cost, the range cost $1,700 and an electrician was $450. But I also noticed the exact same model in the gas version was the same price, $1,700. So if you're already doing a renovation or replacing an old stove, your cost is essentially zero, aside from what if you need to put in a new electrical feed. In terms of utility savings, the amount of actual energy used on cooking is pretty low compared to other household utilities. So the savings were pretty negligible, but I did have really significant sanity savings. So the next thing that I want to talk about, this is the last piece, was installing the heat pump. So here's a photo of my house before and a photo after. Not much changed. The heat pump is a slightly larger. I upsized from a 2.5 ton AC to a 3 ton, but it was narrower, so I have more room to schlep the garbage cans to the street. So what's a heat pump? A heat pump uses a refrigeration cycle, which I'm not really going to talk about, to transfer heat from one location to another. You might be shocked to know that you already have heat pumps in your house. So a refrigerator is a heat pump. It transfers heat from into the fridge to outside the fridge to keep your food cold. An air conditioner is a heat pump. It transfers the heat from inside your house to outside your house. The only difference between this new one and this old one is it has what's called a reversing valve that allows it to operate backwards. So you can pull heat from outside and reject it inside. So here's my old furnace system. The air comes in from the house. The fan blows it across the gas burner in winter to heat the air. It goes back to the house, goes around and around. In summer, same thing, fan blows, gas burner is off. The air conditioning cooling coil cools the air and it goes around and around. So this was the retrofit. It was essentially exactly the same procedure as replacing the air conditioner. Took out the inside coil, took out the condenser unit, put in some new refrigerant lines, and that was it. The gas burner was still there, kept the same fan, same furnace. I kept those as a backup in case I needed it over winter, but I didn't end up using it. So that's simple. Any contractor can do this install. A very, very simple process. The only difference now is the heat comes from this coil in the summer. You've got cooling here. The heat goes outside. In the winter, you got the heat coming in here and cold air is blowing outside. So the old fossil heating was about 94% efficient, which is pretty high for a gas furnace. And you might think, 94, that's amazing. Like, how can we get better than that? But the key thing here is a heat pump's not generating the heat. It's just moving heat. It's using electricity to move heat. So you can move more heat than the actual energy you put in. And what that translates to is about 250% to 370% efficiency. So for each 1 kilowatt hour you're putting in, you could be getting 2.5 to 4 times that amount of heat out of it, which is kind of amazing. It seems like magic. A few things to consider with replacing your AC with a heat pump. There's my handy dandy cooking thermometer there. Shows the temperature coming out of the supply is about 33. Usually it's around 30 to 35. So it's lower than a fossil fuel furnace, which would typically, I measured it around 50 Celsius. So when that thing comes on, it blasts you with warm air. You feel that warm hug of heat. But at this temperature, 33, you don't get that blast of warm air. And some people might sense that as being kind of cold. So I think that's possibly one of the reasons why contractors are more tentative when it comes to installing heat pumps. But at the end of the day, here's my thermostat showing the house is 20 degrees when it's minus 11 outside. So it works. You can heat your house with a heat pump. I talked before about my aggressive thermostat setbacks. Interesting thing, I stopped using all of those when I got the heat pump. Basically, any runtime savings at night was offset in the morning because with the lower discharge temperature, it takes longer for the house to heat up. So there's no point of having setback. So a side benefit of the heat pump was less complaints from my housemates because it wasn't like 16 degrees overnight. One thing I didn't do was try higher temperatures. I know not everyone likes 20 degrees, but I was trying to prove this business case, so I just did what I would normally do in winter. This winter, maybe I'll try a month at like 22 or something to see what the impact is. But this analysis is based on the house being 20 degrees all the time. Because it takes longer to heat the house, your fan is running more in winter, so the filters get dirtier faster. You might want to check them a couple times throughout the winter. Outside, when you're heating, the coil is really cold, blowing cold air out of the house, or not out of the house, but blowing cold air off the coil. So if it's really humid out, you can build up frost. It automatically defrosts and there's some water melting. You just might want to consider that when you're locating it. Mine's on concrete, which is annoying. I just put some salt down when it's cold out to make sure I don't have ice buildup on the ground. And then another key point here is didn't need an electrical upgrade. I just used the same breaker that was already there for my AC, which is kind of key from an infrastructure standpoint, right? The size of the cable coming to my house didn't have to change. I am using a bit more electricity, so the utilities are going to have to figure out how to generate more electricity if a lot of people do this, but you don't need significant infrastructure upgrades to each house because I didn't upsize my electrical feed. So what was my upfront cost? Around $4,700 after tax. One thing I've noticed, there are much more expensive heat pump systems available, and everyone I've talked to that's been quoted a heat pump, their price has been like $15,000, $18,000, and I think what's happening is contractors are tending to quote the most expensive option. I'm not exactly sure why. Maybe it's because they're uncomfortable or inexperienced with heat pumps. They just want to go with like the bulletproof solution. But I think I've proved here that it doesn't need to be that expensive. And just doing it with the central AC seemed to be the most cost-effective way for me. Interestingly, I asked the contractor, how much more does this heat pump cost than just replacing my air conditioner? My air conditioner was old and rattly. I probably needed to replace it anyway. And they gave me a quote for that. And the heat pump was only $800 more. So there's not a lot of added cost here to cut fossil fuels if you're already doing another project. Savings, gas savings, $211. Using more electricity, so there's an added cost of about $400. but my old air conditioner was pretty bad, and I'm saving about $85 a year on air conditioning because the new one is way more efficient. And then here's kind of the rub. If you can cancel your gas account, you save on the account fees, which in my case were actually higher than the gas charges themselves. So after I didn't use gas all winter, I was comfortable in canceling my gas account. They just put a lock on it, like all the pipes are still there. They put a lock on the meter. But my total savings were $200 per year. So, and it's kind of contingent on canceling the gas account, which is why you have to go through all those other steps too. In terms of some fun charts I put together, here's a chart kind of showing the green dots here are the runtime fraction at various outside air temperatures. So in the coldest temperatures we had last year, it was running about 65% of the time. So I followed this line to 100, and it's about minus 25 Celsius. I looked up some old stats. The average number of hours at minus 25 in the city of Toronto is 0 per year, 0 hours per year. It has gone below 25 degrees Celsius in Toronto one day of my life, which was in 1994. So I was pretty confident in canceling my gas account at this point. I still plan to buy a couple of plug-in space heaters just for like a backup in case the fan fails or whatever, but I probably should have done that with the gas furnace as well. Here's another fun chart. The red line, the red bars show the heat output from the heat pump. You can see it's pretty stable throughout all the temperature ranges, which is awesome. The blue dots are how many defrost cycles I measured. So there's about 20 defrost cycles all winter, and they're very predictable. It was around freezing temperature when it was snowing, when the humidity was high outside. And I know, okay, it's going to do a defrost cycle. I'll put some salt on the sidewalk or whatever. But if you're able to find a spot over gravel that you're not worried about the water, then you don't even have to worry about that. So that's what I did. Let's look at the overall combined results now. My total upfront cost, under $10,000 for the entire project to decarbonize my house. If I look at the cost, added cost over business as usual, it goes down to $4,000. So I mentioned like going with a induction stove over a gas range. There's no incremental cost. The heat pump only costs $700 more than doing the AC project. With the water tank, I'll talk about this. My rental contract would have paid for a new water tank for gas. So the entire cost is incremental, even though an electric tank is cheaper than gas. I had to put the whole thing on because I'm counting the savings from the tank rental contract. So my total savings were almost $600, and that's a 7-year simple payback, basically only getting the rebate for the installation. I wanted to quickly compare this to the average household renovation spending in Canada, which is about $5,600. So I think that kind of puts these numbers into context. They're not totally out to lunch. And another key point is that, as Ariana mentioned, some of these projects are now eligible for the Canada Greener Homes Grant. So you could actually perhaps reduce your incremental cost into the negative by switching away from gas and have an instant payback. Here's kind of the trend over time of my total utility cost. This blue line is 2020, starting from January, and it shows the timeline of when I did each project. So you can see it was pretty quick. I was able to decarbonize the entire house within a 5-month period here between June and November 2020, within the first year that I was living here. So the idea that it's hard or can't be done fast, I feel like it's kind of dispelled with my experience. You can see my heating costs in winter, my utilities were similar costs to before, but in the shoulder seasons here in spring and in summer, drastically lower, primarily due to kind of bill consolidation. I'm not paying the $40 a month for the gas tank. I'm not paying the $25 a month for the natural gas account. And my air conditioning is so much more efficient. That was a really cool chart there, just showing the results. This is kind of the key slide, the CO2 reductions. So I went from 1,000 cubic meters of gas to 0. I increased my electricity consumption about 87%. Now, as I mentioned, 1 cubic meter of gas has about 10 kilowatt hours of energy. So my total energy actually decreased by almost half just by electrifying the house. So the idea that natural gas is efficient is kind of debunked here. The CO2 emissions went from around 4.6 down to 0.26. That's including the electric grid emissions factor, and the gas emissions includes the fugitive emissions that I talked about before. I typically buy renewable electricity automatically, so this goes to 0 for me, but if you're fine with 0.26, you can do that too. Key other thing I wanted to highlight, carbon tax. So I don't know if you saw these announcements a few months ago, but the feds are planning to increase the carbon tax to $170 a ton by 2030. So what's the impact on my 1,000 cubic meters of gas? In 2020, that was costing about $57 in carbon tax at $30 per ton. But at 170, that's now $325. If you're putting in new fossil fuel equipment now, in the next 5 to 10 years, you're not just going to be burning fossil fuels, you're going to be burning money too. So I mentioned I was going to talk about a couple of extra scenarios. This one's if I had owned the gas-fired hot water tank and had no rental contract. So now my added cost of going electric is much lower because, as I mentioned, the electric tanks are about $200 cheaper than gas. So it's just the extra cost of putting in the wiring. My total cost is now, incremental cost is under $2,000, but my savings dropped. I don't have that sweet $400 savings, and I'm down to $100. So we're at like an 18-year simple payback, which isn't great, but once again, bam, $5,600. Some of these measures are now eligible. I was not able to take advantage of this. I did this stuff before this program existed. So your payback on your added cost could be instantaneous. Another scenario, so I mentioned the carbon tax going up. If I assume an average carbon tax of $100 per ton, in addition to the previous assumption, let's see what the impact is there. So this is all the same, but now my gas is going to be more expensive and my savings are $300. So even without rebate, it's a 6-year simple payback. But with the rebate, once again, you could get instantaneous payback, which is awesome. So a little bit about why I succeeded. I want to acknowledge, it cost $10,000. Not everyone can pay that. I'm lucky and privileged in many ways. I'm privileged to have a stable job and savings to pay for the project, and especially to have kind of the educational background to navigate like the vacuum of information. Privileged to own a home and have control over my own energy sources, and very few people have all these advantages. So that's kind of the crux of my presentation here, trying to share this information so other people can use it in their favor. Another big advantage I had was the previous owner replaced the windows already and had added wall insulation. So that was a big cost that I didn't have to incur. So what am I saying here? What can you do? You can use my story to take action as an inspiration or whatever. Everyone's not an expert in building efficiency. If you want to use this story as an inspiration to do something else, use your own skills, that's awesome. You can take it, use it, apply it to your own house, or apply it to something else totally different. I want to talk about you can talk about your actions when you do them. Talk to your friends, contractors, government, everyone. Make sure they know you don't want to burn fossil fuels. Ask contractors about it. If you're doing a project, ask them if there's a non-fossil fuel option. Like I mentioned, you should try to have a plan in place. I mean, it's not totally fair to put this on people that have all kinds of competing priorities, but the fact is contractors don't have this priority right now, so you need to have a plan in place until they do. A lot of rebates were mentioned. There's also resources, including the BetterHomesTO website. It has a lot of resources on greening your home. The main thing here is I found there are no technical barriers in the Toronto climate to decarbonizing residential houses. The only thing really that was difficult for me was kind of overcoming this status quo bias. Every time I was wondering, am I the crazy one? Is this going to work? But it turned out it did. So that's kind of the main point here. And then I wanted to highlight this myth busted. So fossil fuel consumption 0. I cut it to 0 on all my heating and utilities. I saved money. It's not more expensive. Electric can be cheaper than gas, and it didn't cost a totally obscene amount in the grand scheme of things. This is well within the capability of the government to help people overcome. So let's try to change the conversation here. I'm going to bring back the kind of old-timey Batman comic book phrases here, and I'm going to change them a bit to how I think we could change the culture a little bit. Bam! Going electric could save money. Boom! We will make sure the system works for you. Gosh! Cut fossil fuels and live sustainably. How? Electric is more efficient. So these are some of the ways that I think contractors need to be talking instead, and not just contractors, but all stakeholders, to make sure people realize this is real and it's doable. I'm going to move on to the questions. I want to thank everybody for listening, and I'm going to end off with kind of a little dad joke I made up. Why did the gas appliance cross the road halfway? Because it was too inefficient to make it to the other side. And there's my email if you want to contact me with any more questions or comments. But I'm happy to turn it back over to Ariana if any questions came up while I was talking.
Thanks so much, Mike. Great presentation, and we love the dad jokes and the sound. So thank you for that. So we did have a couple of questions, particularly around the rebates that I tried to answer during your presentation. So sorry about that, guys, and thank you so much. But I do have a whole list of questions, so let's get to them. So the first is, what percentage of climate change is caused by the global poor versus us, the global rich?
I don't have the exact percentages, but I think those can be looked up pretty easily. And it's pretty well known that the global rich have a much larger burden of responsibility for historical and current emissions.
Thank you so much. Alrighty, so we have another question. Are there high efficiency electric systems to replace separate gas hot water heaters and boilers for hydronic radiators, heat pumps, geothermal? What demand does this have on the electrical panel?
So as I mentioned on my project, there was no change needed to the electrical panel because I was just reusing the existing. I'd have to look at it on a case-by-case basis. In some cases, hydronic systems can be harder to retrofit because they might be designed for a very high water temperature that can't be met by heat pumps. But in many cases, you can either switch out your radiators to lower temperature radiators, and then you can provide that temperature with an air-to-water heat pump. And in many cases, like a radiant in-floor system, usually the temperatures are pretty low on those systems, and a heat pump can usually be directly applied to those.
Great. Someone else asked, apparently 85% of HVAC renovations occur during breakdown. Any way to reduce the risk to installers to encourage this kind of proactive behavior? So I guess that's your proactive behavior, Mike.
Yeah, I mentioned that in my presentation. Like, it's tough. Like, if something happens in an emergency, you kind of have to go with what's available. And currently, what's available is going to be typically fossil fuels. That's what contractors know. They can do it faster. They're more comfortable with it. So that's kind of why right now, unfortunately, the onus is on people to come up with a plan in advance.
That's what we like to hear. Thank you so much. Another question, we've actually had a couple of questions on this, Mike. Have you considered or done any solar installations on your house yet?
I just wanted to touch one other point on that last question. The interesting thing to me was, so I was replacing my failed air conditioner. It wasn't failed, it was just running poorly, but I kept my furnace as a backup. So there wasn't too much risk in terms of doing that, and I had a backup in case the heat pump wasn't sufficient. So in terms of an emergency, this was kind of a thing that could be done in a non-emergency situation. Regarding solar, I have looked into it. I haven't gone ahead with it yet, mainly because the electric grid in Ontario is already pretty clean. However, that might not always be the case, so I am interested in looking at a solar project eventually.
Great, thanks so much. Another question, what's the best option to replace a gas boiler? Is it a heat pump? We like the radiators and have no ducts anyway.
So yeah, that's kind of similar to the other question. As I kind of talked about, the temperature coming off of a heat pump is lower, and depending on what temperature your radiators are designed to operate at, you might need to replace them. You might need to change the pipes in order for a heat pump system to work. If you were to go to kind of a resistance electric boiler, it would increase your utility costs a lot more because you're not benefiting from that really high efficiency. Like an electric boiler is around high 90% efficient. So you're still going to have a pretty high electric cost in that scenario.
Wonderful, thanks so much. Someone also made a comment on the Greener Homes rebate that they were told that the normal heat pump is not eligible, only cold climate heat pumps are. And said that the contractors also claim that the heat pump is only efficient to 0 to 5 degrees Celsius. So there is an electric furnace component to compensate. So they're looking forward to a conversation with their energy advisor about this, and feel free to reference this wonderful webinar, which we will hopefully provide.
That's fantastic. Yeah. Like that's exactly what I was talking about. Like this one that I installed is a cold weather. It supposedly works down to -30 Celsius. And my data suggested that I won't even need a supplemental resistance heat until it gets down to -25 out. So I think that is, in our climate, definitely something you can push back on with your contractors. And if you're worried about it, you can just buy like a plug-in electric heater, put it in your basement or whatever, and take it out if it becomes necessary. Or keep your gas furnace in place like I did, and test it out for a season to see what happens. And it's not that much risk because the added cost of over an air conditioner is pretty low.
Sure is. Thanks, Mike. Somebody also asked about your barbecue. Have you converted that too?
I have not, and that one is kind of interesting. There aren't that many electric barbecue options available. So I do still use the propane tanks. To kind of put it in context, the amount of emissions from one tank of propane is around 26 kilograms per entire tank of propane for a barbecue. So that's 0.026 tons. So it's kind of not really in the same range as the rest of the house, but it might, saying I'm at 0 might not be totally true if I have like a tiny sliver of emissions from my barbecue. But there aren't that many good electric barbecue options right now.
Thanks, Mike. Everybody.
And just here though, there are electric barbecue options elsewhere. Like they're not that uncommon in Europe. It just doesn't seem to be a thing in North America.
We got to change that, don't we?
Yeah.
All right, another question. since electricity rates changed several times during 2020 and 2021, how did you deal with this in comparing energy costs from before and after your changes? Good question.
So yeah, that's very interesting. Maybe I can go back to my slide about that. Where my utility costs were, right here. So yeah, in January and February, I think, 2021, electricity was being subsidized. So this number was a bit artificially low, but at the same time, I didn't cancel my gas account until April. So I was still paying gas account fees here that I wouldn't normally be paying. So I kind of treated it as a wash and didn't think it was worth mentioning, but because the account fees would shift it down, and then the normally higher electric prices would shift it up. And actually, in my overall results numbers here, I used the regular kind of per kilowatt hour price of electricity. I didn't include the artificially low subsidized prices in my savings numbers. And another thing I should mention, because the weather isn't the same every year, what I did was I created a model for my utility consumption based on the weather in 2020, and a separate one based on my consumption after the retrofit. And I applied both of those models to the 5-year average weather for Toronto. So it kind of provides an apples to apples comparison, even though the weather might have been slightly different over the 2 years.
Great, thank you. Okay, Mike, somebody else asked, do you have any thoughts about heat pump water heaters over electric water heaters? I think you spoke to this briefly in the presentation, but if you could reiterate.
Yeah, it sounds, I definitely considered it. I'm just scrolling back to my last slide here. I considered it. The cost of a heat pump electric water heater was more than double. I think they're around like $22,000 or $2,500. So that was a consideration, but they do use way less electricity. Like my business case numbers might have looked a bit better. At the end of the day, I kind of erred on the side of the keep it simple principle. A heat pump unit has a compressor, lots of moving parts, more things to go wrong. And I just chose to go with a resistance system that had a really long warranty that I knew was going to be pretty reliable. Not that those other ones aren't reliable, that's just what I decided to do.
Awesome, thanks, Mike. So just looking at the time here, folks, recognizing it is 2 p.m., so I understand if some of you do have to jump off, you're welcome to, that's all good, totally understood. But we will stay on, for a little longer. I see there are still questions in the queue. So thanks again for joining us. If you do have to jump off, so glad you could make it. And for those of you who can stay, we're gonna power through some of these questions. So somebody else asked about, are there contractors who specialize in heat pumps, or perhaps a website that we can kind of send people to? Was there anything that you did, Mike, that to find your contractor?
I just found them through like a Google search. There are ones that specialize specifically in decarbonizing homes, I think. But kind of like I mentioned, the heat pump I installed was the exact same process as installing an air conditioner. So it truly didn't really require a specialized contractor to do it. The one caveat there is selecting the right heat pump and size of the system. I kind of worked with them on that and with the manufacturer. So that's something you have to consider when you're selecting your contractor. I'd be happy to share their names if people want to contact me separately. I don't know if the city likes promoting specific companies or anything.
Unfortunately, we are unable to promote specific ones, but we are working on, compiling lists of, various, registered energy advisors, but also, coming forward and, one of the areas where you may be able to do this in the future, this is in the works, are certain renovators and contractors who go through a net zero homes kind of training. So that's coming up in the around the end of the year. And again, we'll provide more details on that when that comes, but that is in the pipeline. And yes, we will be hoping to share resources on that as it unfolds.
And I think that's the beauty of the Greener Homes Grant program. There's more of a focus on emissions reduction, whereas the old rebate program was kind of focused on putting in more efficient gas equipment. And there wasn't really, it was all kind of around fuel efficiency, whereas the new program is more focused on greenhouse gas emissions reduction. So I think those audits, you might be able to direct them a bit more on what you're trying to do.
Yep, sure can. I think that is the idea behind it. And somebody else asked, Mike, do you have a dollars per square foot for your renovation, all in, like, you know, an estimate of that?
Yeah, I mean, it was around $10,000 and my house is 1,500 square feet. So what does that work out to? Like six point something?
About right, yeah. But the person said $6 to $7 per square foot, approximately.
Yeah, I'm not exactly sure if that makes sense to, like, if it's going to work out exactly. Like, it might not scale perfectly on a larger or smaller house. So I don't know if that metric has too much. It could be useful, but I'm not exactly sure how it would apply.
Yep. Okay, awesome. Someone else actually provided us some information. Thank you, Lee, on getting a stand-in CO2 heat pump that has high output for the gas boiler replacement situation. But just a note there, it would slightly be a bit more costly in that scenario, and sizing is important. So something to keep in mind, and a little caveat there.
And that's a good point. The interesting thing about those heat pumps is they use carbon dioxide as the refrigerant. So many other air conditioners and heat pumps use refrigerants that are really bad in terms of global warming potential. For example, if all the refrigerant leaked out of the heat pump I got, I think it would be around 3 tons equivalent of CO2 emissions, even though it's only like, I don't know, 600 grams of refrigerant in there or something. So there are benefits, and I'm hoping more CO2 heat pumps become available. That stand-in one's pretty interesting because, yeah, you can use it for high temperature hot water and also for different heating applications. But it didn't totally make sense for my house because I had a forced air system. And it was more expensive, a lot more expensive upfront, and I was trying to prove that this could be done cost effectively.
Which you did, so thank you. Another question, and we kind of have touched upon this, but you know, I'll still bring it up. Do there exist home energy consultants, i.e. someone like you, Mike, who will help less knowledgeable homeowners make a long-term plan to decarbonizing in a similar manner as you did?
So this is kind of the key question, right? People need someone to help them navigate through the void of information on this topic. And I think part of that Greening Homes grant is directed towards training the auditors to be more helpful from that standpoint. But overall, it's like a really long-term culture shift around contractors, utilities, all kinds of service providers, and there's not really any silver bullet solution to that. Although one interesting one I heard was just incentivizing the air conditioner manufacturers to just make every air conditioner a heat pump, and then they just automatically get installed all the time. Just subsidize the manufacturers and then train the contractors on how to set them up, and then that would look like a pretty interesting way to do it.
For sure. And I'll also mention briefly that the city is working on something similar to this to kind of help people who are really thinking and want to decarbonize their homes to do just that. So we're hoping to launch more resources as that becomes available, and perhaps maybe even a position of that manner, which can kind of provide more objective advice to homeowners who are really looking to decarbonize. So again, stay tuned. We should have more information on that later this year. Mike, also another question. Have you looked into a gray water toilet system?
So trying to recover rainwater and use it to flush toilets. I haven't. I have no information on that. Some of the buildings at the hospitals I work at do use those kind of systems, but they are pretty maintenance intensive. The water has to be treated. You need two separate sets of pipes and pumps, I guess not pumps here, but you need two parallel systems in case there's no rainwater. So it is pretty hard to implement.
Got it. Okay, great. Thank you. And another question. Someone is looking at a replacement for their water heater, and they're looking into inline water heaters. So one heater for each hot water tap. Looks less expensive, less electrical wiring, and you may not need to wait for the water to get hot while heating the pipes. Thoughts?
Yeah, sounds feasible for sure. In terms of electrical wiring, you would need, one wire going to each bathroom and appliance, or maybe individual appliances too. So there would definitely be some wiring involved, but it would be nice to have instant heat, not waiting for the water to heat up.
Awesome. Okay, thanks, Mike. Lots of questions in the chat as well. It looks like I think I got through everything in the Q&A, so I'll just go up here quick. So somebody asked, the existing building strategy estimated the average cost per house will be $166,600. Why the huge difference? I'll just quickly, put a caveat in there. This modeling for the existing building strategy was done, kind of on a more, inclusive scale, taking into account multiple different options. So again, that was more, just trying to get an idea of what that would cost. And I believe it also, includes buildings and such. So yeah, those numbers are, again, a big estimate and take into account multiple different housing types. As Mike mentioned, every house really is truly different. And so cost can vary from house to house. This is just one example, of a retrofit for his type of house, the square footage and all of that stuff, because that does take into account. So just a caveat there. Anything else to add, Mike?
Yeah, I guess the key things that I didn't have to do were replacing windows and insulating walls. And the windows could be expensive, like that itself might cost more than my entire project. And I think wall insulation can be done somewhat cheaply, just by cutting a hole in the drywall and spraying insulation in there. But that is definitely something to consider. But yeah, $166,000 for a house definitely doesn't make sense. But like you said, that's considering all different building types.
An average of where they're at, how many, on average, how many, retrofits the average home, for example, in Toronto would need, that kind of thing. So I believe that number is a little bit more skewed to the building side. But again, I would have to kind of come back and confirm. If you would like, kind of more information, please feel free to email us at betterhomesto@toronto.ca. Someone else asked, how big was your house, and did you have any skylights in the house?
As I mentioned, yeah, the house is 1,500 square feet. I have two skylights. In winter, I do put like a plastic film over the skylight to try and prevent heat loss out the skylight.
Got it. Awesome. Lots of people saying, thank you so much. They're inspired, they're excited, they're going to work towards their retrofit, which is like the only thing we wanted. So congrats. Thank you.
Yeah, let's do this together. Kick the habit.
Let's do it. We can do it. Someone else asked, where does the heat for a heat pump water heater come from? If it is inside the house, how is that heat produced?
Yeah, so that's another consideration I had with the heat pump one. Basically, it's just pulled from the ambient air. So if you have it in a garage, that's fine. Your garage just gets cooled down slightly when it's producing hot water. But if you have it in a basement, I was slightly concerned like the basement might get colder, or I might have to, run some duct to the outside to like discharge the cold air outside the house. So that was part of my thinking around the resistance hot water tank as well. Like I wouldn't have to worry about any of that stuff or think about it.
Awesome. That's great. And then lastly, do you have any thoughts about the CO2 heat pumps? So we did talk about that a little bit earlier, but any other thoughts?
Yeah, they sound awesome. They can produce higher temperatures. They don't have high global warming potential refrigerants. Obviously, CO2 has a global warming potential of 1 versus like 2,000 for some of the other refrigerants, or even up to 4,000, I think. So I think that's definitely going to be coming up in the future. I'm hoping when this heat pump I got craps out that I'll be able to get a CO2 one next time.
Awesome. All righty, well, I think we made it. We did it. We got through all the questions, and thank you all so much. You really had some great questions here, and I'm so glad you could all make it, and that you could try and help with some of your retrofits, or if you're thinking of them. And I think Mike, thank you so much for joining us today and for sharing your story. I think this information is amazing, not only for other homeowners and residents, but also even people in the industry, because we tend not to see, especially with respect to costs, that tends not to be a kind of part of the narrative often. So we really appreciate you being here today and for sharing your story and all of the wonderful details that you were able to share with us, and for answering everybody's great questions too. That was awesome. So again, we have recorded the session. I'm hoping to, again, share it with you all when, the time comes and we have a copy. So stay tuned for that. And if there are any outstanding questions, of course, please feel free to email us at betterhomestO@toronto.ca for any outstanding questions. Or Mike has very generously put his email there for any questions here. So if you have a burning question for Mike that you'd like to get answered, please feel free to email him as well, or through us at BetterHomesTO, and we can forward it on to Mike as well. Thanks again for joining us, everyone, and have a wonderful rest of your afternoon. Yeah, we hope to see you soon on other webinars that we hope to launch later in the fall. So thanks so much all, and have a great rest of your day.